Fantastic. As I say, a very exciting topic, but maybe one that's a little obscure for those of you who don't follow electricity markets. And so I'm going to start off maybe with you, Steve. Can you tell us, first of all, when you think about this big question that everyone's dealing with, that is these hyperscale data centers that are turning up, that have created a political uproar in Ireland. I was just in Dublin, where there's been a backlash. I was in Virginia. People who've been in this room know a few days ago, because there's a story that I've written that's going to be published later today in The Economist on this topic, where people are looking at these data centers and saying, you're the reason we're having price inflation, that this is creating a major crisis. President Trump in the State of the Union made a reference to this, and tomorrow is marshaling the big tech bosses at the White House to get them to sign a voluntary pledge on this topic, that they won't force Granny to pay for prices for their data centers, which are, according to a recent report from Goldman Sachs, going out of control. If you were to believe the report, the AI-related electricity demand is going to be a dominant driver of price inflation, and even pass through into macroeconomic inflation and national inflation. So I'm a little skeptical about this, so I poked around. But let's hear from you here, because you have a perspective on this topic about what happens when these big data centers turn up. And you've also had a recent trial, and we want to hear a little bit about the news today from you and Varun. But first, kick us off with the big picture. How do you see this issue?
Yeah, so look, the big picture is it's a slightly strange world to work in an industry where you get a bunch of big, well-resourced companies coming and saying, I'd like to use a lot more of your product, to which the answer is, oh, this is all a nightmare. And, how am I going to cope with it? And it's going to push prices up. So the simple answer is, if you do this in a stupid way, if you connect these large data centers without flexibility and in the wrong locations, it could have that impact. But that's just a really dumb way of doing it. So most electric networks, most electric power systems operate, at probably 30% of capacity for most of the year. There's lots of capacity on the system. It's a small number of hours of the year when we're at peak that we're strained.
It's designed for the 20 hours of peak or something a year.
Yeah,
am I right?
So in this country, it will be typically between 4 o'clock and 7 p.m. on the darkest winter day. Think about that. That's when our system's stressed. For most of the rest of the year, no problems at all. So the trick to how you do it, and this can be great for ratepayers and great for customers, because if you can throw more electrons at a fixed cost system and you don't need to build more infrastructure, then rates come down for everyone else. And the two ways you can do that is being careful about where you put them physically. So what's the location? But actually, even more important than that is if these data centers can offer a bit of flexibility. So if during those small number of hours when we're stretched, if we say, can you actually moderate your load when we need you to, then we don't need to build lots more capacity to put you on. And then you get this marvelous flywheel effect of, as I said, you bring them on, they're paying towards your fixed costs, and therefore it's good for ratepayers. So what we've been working on with, with our partners here, so with EPRI, with NVIDIA and Emerald as a thing, is how do we get can these data centers flex their load? So if we say to them in a particular half hour, we need you to come down or come up, can they do it? And probably Varun should talk a bit more about how Emerald do that and the trial that we've run.
Now, when I began pushing on this topic a couple of years ago, when this began to be an issue, the initial response from big tech companies, save one or two of them, but certainly from data center operators, was, oh, no, we can't be flexible. Our customers, data center operators would say, well, I can't make my customers be flexible. They all want it right now with no interruption, no delays, nothing. And even the big tech companies said, look, this is too important. We have to serve this load. We can't tolerate any delay, any latency. Everything is mission critical. All is equally important. It has to be right now. It turns out that's not quite the picture. Am I right? Can you tell me a little bit more of what you've discovered?
Yeah, I always think that necessity is the mother of invention. So look, if you're trying to deploy at the speed and scale there, of course you start with, in an ideal world, we want everything. We want you to connect us as quickly as possible, and we'd like these massive ramp loads, and we don't want to have flexibility. When you start explaining to them the physics of electric power networks and why that's hard, and if that's what you want, it might take quite some time, then I think people actually rethink the problem, or when they rethink the problem, they actually realize that they can offer flexibility. Now, Varun and Emerald is a software solution to that, actually understanding what within that data center load is time critical. Because often we're only talking about shifting, by half an hour or an hour or something like that. You can put batteries behind them, on the data center. You can put, generation on their side of the meter. But fundamentally, I think we've been on a journey of discovery together where they started there and said, we want everything, and we want to be on fast. When we said, that's going to be difficult, then they have discovered that actually there's more flexibility than they thought.
Great. So obviously, here in the UK, your firm has a lot of credibility. People understand what you do. So when you speak, it carries some weight. There was some news announced today in a press release jointly put out by you all. And Varun, I'll come to you for the details on what your company does specifically. But let me ask from the man who has a bigger megaphone, what exactly did you announce? Give us a summary of the results, and maybe Varun can pick up from there.
So essentially, we did a test on a data center in London. Now it was small scale, but it was real. So we simulated a number of events, which are the sort of things that we have to worry about when we're operating our transmission system. And we simulated events where we've suddenly lost some generation on the system, and we need the data center to move down its power consumption in real time. We also simulated events. I mean, this is a particularly British phenomenon. We have these big demand pickups when you might suddenly have you got a football match going on, it gets to halftime, everyone flicks their kettle on, and we suddenly see demand spike. So as well as asking the data center to turn down its consumption, we actually said, can you consume more? It'd be really helpful if you could.
Right, the tea kettle phenomenon.
Yeah, exactly. So we've got both of those things going on, where we're saying, if demand's spiking, can you come down? But also there might be other events, and we're saying, can you consume more? And we took all of these real simulations. Emerald had no idea what was coming at them. We literally threw it at them, and some of them were in the middle of the night when we said, you need to follow this load profile. And as Varun will explain, it turns out they could do that beautifully and in a way that would give us comfort in the control room to say, these loads can do what we need them to do.
Right. Okay. So there was a successful outcome of this trial. Now, Varun, explain to us what exactly is Emerald AI, and what is it that you do? Obviously, software that manages, manipulates loads, electrical loads. It's in some way. But again, I think hands up. How many of you know what Emerald AI is? Okay, and how many of you do not work for Emerald AI? Okay, all right. Thank you. So why don't you tell the rest of us normal people what this company is that didn't exist 2 years ago, and what it is you're trying to do?
Well, thank you, Vijay. Thank you to you, to The Economist, for having us here. It's really an honor. I've been reading The Economist my whole life. And let me say I'm flanked by some of my favorite people. I don't say that only because there are large investors, but we're grateful to National Grid and NVIDIA, our investors, EPRI and their DC Flex initiative, who were one of the first folks to believe in us and partner with us to make data centers flexible. And of course, Nebius, which thanks to them, we had access to their tremendous new London AI factory to prove that AI factories can be flexible. So we exist. We're a software company that makes AI data centers capable of modulating their demand, as Steve said. And we think of ourselves as having two masters, kind of like these two gentlemen on both sides. On the one hand, we need to listen to what the grid needs. Like you said, when the tea kettles are all turning on in this uniquely British phenomenon at halftime, the data center can actually provide some relief to the grid by reducing its power for, let's say, 2 minutes or 30 minutes or 4 hours. And so we can do that. And the other master, of course, on the AI side is making sure that the AI workloads that are running, whether you're pre-training or post-training, fine-tuning, running inference of these models, that happens to the customer satisfaction. You got to do both at the same time. So today, delighted that we have this UK-first demonstration of AI power flexibility, which all of us together jointly did. And as Steve mentioned, for the first time, we've proven on this AI Blackwell Ultra NVIDIA GPU cluster that when we get the signal, middle of the night, lightning strikes, we're able to reduce power within 30 seconds by over a third, 35%. Or when the renewable energy, the wind is at a low, these doldrums, when there's low wind, for 8 hours, the AI factory is able to reduce its consumption. And we do it in such a way that we protect the critical workloads that run at 100% throughput. This is kind of a critical moment on the journey. Along with Anuja and EPRI, we've done now 5 different demonstrations at commercial data centers in this escalating pathway of capabilities. And later this year, with Josh and NVIDIA, we'll launch the Aurora AI Factory, NVIDIA's AI factory that, for the first time, will be the world's first power-flexible AI data center at 100 megawatts in Manassas, Virginia. You said 2 years? At that point, we're 16 months old. Later this year, we'll be 2 years old. And we will have taken this technology from lab bench invention to commercialization at a commercial data center in just 2 years. I hope that's a great story for the climate tech field that, Vijay, you've been an expert in covering, compressing that timeline down to 2 years.
Great. So this is an exciting story, but you still have to tell us a little bit more about how your secret sauce works. Because if do you tag workloads into, very important, less important, delayable, or, give us a little bit of an idea of how exactly you do this.
If I back up a level, remember, these AI workloads, some of the most critical work in human history. These are economically productive workloads. We don't want to be messing with them too often. But there are 3 ways that you can achieve flexibility and power from workloads. The first way is you can slow some down or pause them, maybe a fine-tuning model run that doesn't need to finish right this second, but it can be delayed by an hour. You're only going to use it next week. The second way is by moving AI workloads. You might have, Vijay, you may be asking ChatGPT a question. You expect your answer pretty soon, but we may be able to move it, as we did with Anuja and Epri from Virginia to Chicago. We moved it between 2 different Oracle data centers at the rate of 10 milliseconds of latency, and you never noticed the difference when you got your answer.
So there is a little bit of a latency penalty, but not relevant for that workload.
And the third way, and Anuja and Epri are doing a lot of work on this, the third way is to put batteries or generators or fuel cells or something else on your data center to achieve some flexibility. Emerald is kind of the software brain that thinks about how can we use all 3 of these in an optimal way to give the grid what it needs while protecting the integrity of the AI workloads for the user. And so in this particular trial, yes, the user was tagging workloads. We had simulated users who said, some of these workloads really important, don't touch them. Other workloads, they're kind of medium priority. You can slow them down a little bit, but not a lot. Other workloads, I don't mind if they are delayed by 2 hours. And we made sure that we respected all of those constraints while still meeting exactly what Steve needed, which is, hey, lightning struck. And now Varun, or no human, Ethan's in the audience here, none of us are going to do this by ourselves. There are autonomous AI agents. This is the secret sauce that are in there. They're talking directly to Josh's NVIDIA GPUs. They're talking to the job scheduler, and they're understanding autonomously, I've got to meet the lightning strike, and at the same time, I have to protect the integrity of the workloads. That's an optimization problem no human can solve, but AI can.
Great. Okay, so we've got an idea of how you work. Now, Josh, you obviously you're at NVIDIA. What's your interest in this? As I understand it, NVIDIA has invested in this company, but also more broadly, you're promoting the idea of flexibility and even have some templates for people to, your customers to take this up. Why do you care? People buy your chips, you get your money. If I'm flexible, inflexible, you win either way. So why are you in this game?
Well, I'll give you one answer from that corporate perspective from NVIDIA, and then 2 relating specifically to sustainability. Number 1, as Varun mentioned, if you want power now, we have a bit of a supply-constrained market for energy. So getting connected faster so that we can bring more AI online to start doing that productive work that we all want done, that's a real business opportunity for us to deliver AI faster than we would be able to otherwise. On the sustainability front, there are 2 effects of this demand response feature.
Okay, before you get to sustainability, just for those that don't know, this incentive of connecting faster, this is not a theoretical construct, right? I mean, I think we've seen a deal that Google has done it in Michigan and other Midwestern states, where by offering to be flexible, they were fast-tracked for connection. There's some other jurisdictions that are considering giving an advantage to those. Normally, the interconnection queue is quite long. If you can be flexible, if you can help the grid rather than be a burden to it, this is a real speed power solution, is what I'm understanding.
Exactly, right. And that actually relates to the first kind of sustainability benefit, which is that it increases the efficiency of the existing grid resources. So if we're only at 30% utilization, typically, for existing energy generation, then we're leaving so many electrons on the table that we could otherwise be using. And so it allows us to soak up those electrons when they're available, convert them to intelligence, which can be used now or at any time in the future. And then when we're at peak, we can scale back. So what does that mean? That means that the efficiency of the power generation and power delivery goes up, which, at least in the long term, can help us manage prices, make the grid more efficient, make energy delivery more efficient and more effective. And then the second sustainability impact that is really fantastic about this is it raises the relative value of variable generation because it allows us to soak it up when it's available and use it. So it actually drives more value in renewable sources that are variable supply. And it becomes a critical component in the whole virtual power plant concept where you've got variable supply and now variable demand, and you're able to match those in a very intelligent way, which, again, AI ends up complementing really well by helping to orchestrate that type of solution.
I see. Okay. Well, thank you for that. Let me turn to you, Anuja. EPRI is the research body for leading utilities around the world. You're based in Palo Alto, but now really with a broader global remit. Can you tell us, and you head up the DC Flex initiative, as it's called, and to my pleasant surprise, EPRI's really been leaning into this topic. I'm curious, what is the interest, from as a sort of a research body, a neutral body, you're technology neutral, you serve all kinds of utilities, integrated, market-based. In other words, you can't play favorites. And so what's gotten your body interested in this, and what are you promoting? Where do you want us to go with this?
So, Vijay, I have to start by saying, can you guys hear me?
Just hold a little closer to your mouth, yeah.
I have to start by saying, why were you pleasantly surprised? We do great work. You should not be surprised at all. But to get to your question really about why was this an important element, right? So EPRI's real passion is where there is a societal benefit that is larger than any individual member we have. We have members across 45 countries, around 500 plus members that comes in all flavors, like Vijay said. The reason that this was so incredibly important was because almost every one of our members are seeing a pain point right now from the growth of large loads that is making them pause and go, how can we do better? And in particular, data centers was something that came to our board, from our board to our leadership as an imperative to say, how do we rise to this challenge that is in front of us, which is the speed to power challenge? The data centers need access to the grid in about a 2 to 3 year window. But when you think about the scale of data centers that's coming at us right now, which is 0.5 gigawatt to multiple gigawatt scale, our traditional way of serving this scale, large new load, takes anywhere between 7 to 10 years. Steve mentioned the same phenomena happening here. It's sort of observed and experienced across the board, across all of our members, which essentially meant if we can address this in a way that does not negatively impact the existing customer base, then it's a win-win for everybody. That was sort of the rationale for us. And when you think about it, it had like 2 really interesting research questions. One was this idea of, can these large loads actually be flexible? You asked that question. Varun gave a great answer. The answer is fundamentally yes, even though 24 months ago, we started the journey with particularly data centers saying, I'm not interested in flexibility. Right. Part of it was change in the conversation about how do you deliver flexibility, right? Varun's demonstrated I can show computational flexibility without jeopardizing the SLAs, the service levels that's expected by the end customers from a data center. The second part of the flexibility, like how we got the data center community to cross over to I can be flexible, was by pointing out flexibility is not just about like shutting down your compute load. You have other elements inside your footprint. You have an on-site power element that you already designed for. Let's talk about, are you choosing the sort of appropriate technologies for it that will now enable flexibility. So one part of the exciting piece for EPRI was understanding there is an actual technical research element that can move our entire industry forward. The other side of this was we have about a 3-year window to rise to this challenge, and the utilities as an entire segment have little gaps in the current processes. Everything from how do I forecast this load to once I have flexibility, how do I dispatch it? There are lots of little gaps there. So when we thought about it as a holistic problem, there was so much EPRI could offer, and bringing the coalition of our 500 members to the conversation was a real opportunity.
And what do you see as the output of your efforts? Again, because EPRI is respected by utilities around the world, you have the opportunity to either promulgate voluntary codes of behavior or push for standards and that sort of thing in a way that no individual company could do. What's the end game here for you? Where do you see this going?
So when we think of how can we truly offer something transformational that will help everybody in this conversation, we think of it in sort of 2 big buckets of work. One is this idea of flexibility. So how do we create, we think of it as a common language between the large loads and the utility side. We think of it as creating a common language between these 2 major industries, that when somebody says, be flexible, we know what flexibility means. So in about 2 weeks' time here, you guys, everybody will get to see the framework that we are introducing that essentially ties the grid needs that is driving the time to interconnect in such a way those grid needs will be shown in classes that will then allow a data center design at the front end to pick up and say, I can meet any one of these grid needs by constructing the appropriate, right? The idea there is to create a bridge by standardizing what flexibility is by location. You can provide a signal that will accelerate this access to power. That's one set of, if we are able to get that to become part of the fundamental conversation of flexibility, that will unlock so much potential for us to realize that time to power. The second piece is around interconnection requirements. So one of the things that's been fantastic working with both Emerald and NVIDIA, really, being able to understand the changes in new data center load. We've had data centers as an industry for 20 years. But up to about 2 years ago, we were talking about data centers that really had one type of energy consumption profile.
Right.
But the new AI factories, thanks to Jensen, we have a new name for a subpart of the industry. The new AI factories have a very different profile shape, which is driving sort of additional requirement sets that we need to get into the interconnection requirement documents. That's the second piece. If we can guide industry-wide adoption of the basic requirements to be sort of, I don't want to call it standardized because it's not a standard, but a basic foundational set of requirements, we can again accelerate the integration of new data centers in a much faster fashion.
Great. Well, thank you for that. I'm glad you took the time to explain it. We'll look forward to seeing what you come up with in a couple of weeks. And you talked about AI factories, and we happen to have with us Daria, whose company has AI factories in London and elsewhere. Give us your perspective, because you're you're in the business end of all of this. You know, you need to tell us the reality check. Is this going to work for you? What is the ground truth of what you're hearing on this panel here?
Yeah, thanks for the question. And I will just start by saying that this trial is actually a great example how partnerships can improve how we address this AI versus energy issue. So AI infrastructure does not necessarily have to be just a consumer. It also needs to be mindful about the grid constraints. And I would also give another example from the Nebius practice of how AI infrastructure can contribute back to the energy system. And I wanted to mention the example that we have in Finland, where we own a data center, and there we partner with the municipality for the heat recovery. So when building the infrastructure, we also design heat recovery module as part of the cooling system, which basically leverages server heat and gives it back to the heating system, municipal heating system. And it has a lot of economic and environmental impacts for the local communities. So looking from the economic perspective, the fact that the server heat is used, it helps reduce the heating prices for the local communities by 10%. That's the numbers from 2025. This is a significant impact. And then if you're looking from the environmental perspective, from managing your carbon footprint, this results in avoidance of emissions for producing heat for the municipality. And last year, that was 4,000 tons of CO2 equivalent of emissions. And just to give it like a bit of a tangible comparison, it's as if you're removing over 900 gasoline-powered vehicles from the streets. So if you're looking at the scale of a smaller town, this is a significant contribution to the climate goals that they have. So again, linking back to what we started with a trial, with a partnership, you as an infrastructure company, you are a part of the ecosystem of players and partners, and you need to find a solution and be open to experimenting. This is what we also started the session with. We had this experiment running in our data center, and we're happy to be a part of it. We're open to this partnerships because this can actually open great opportunities to give back to the energy system. So yeah, that's our perspective.
Okay, well, thank you. We have time for some questions. If we have any, if we can get the house lights up a little bit, let's put these guys to the test here. I see a hand in the back. Let's get a microphone there. And I see one closer to the front. We'll come over here next. As always, please identify yourself.
I'm Paul Wilson from Smart Cities World. So I've been reading that AI will use as much new power as Japan by 2030, according to the International Energy Agency. This is like a whole new country on the face of the planet within 5 years, whilst we just don't have enough energy. So it's alarming, isn't it? And it's been very concerning for many of us. Are you telling us you're coming up with a clever plan here?
All right. Who wants to take that? Steve?
One of the things that we haven't talked about is the impact that AI is going to have on underlying, energy demand. I mean, just the opportunities for better use of, air conditioning, downstream logistics, which will not just cover electricity, but oil, gas, fossils, everything else. So I think you have to be slightly careful with those sorts of things, because you can predict the amount of power AI is going to consume. The thing that's harder, but there are good tangible reasons to believe everything we've touched with AI so far, where we've asked it to think about these problems, it's delivered. So I think you almost have to see some of this as an investment in time, that the training of these models and the investment is probably going to pay back, 5-10 times over in terms of some of what it unlocks downstream. And that's before you get into things like material science and the breakthroughs we could have in the production of energy. So I wouldn't see it as long-term adding that much demand to the system. I'd see it as a net negative, but there will be a timing issue, as I said, because you've got to train the models, you've got to build them before you start to see some of those downstream impacts.
Josh?
I'd also add that load growth historically hasn't been a bad thing in terms of economic development, but also in terms of sustainability, especially when we're on the threshold of clean energy being more economical than traditional fossil fuels. This is actually a fantastic opportunity where new economic value is driving new investment in the energy sector that I think will lead to more sustainable outcomes and more kind of economic development around energy as well.
Anuja, then Varun. We can go all around, but just make them short. Yep.
Yeah. I would say the basic answer to, is it going to grow that much? Is it true? The answer is very likely yes. Now, we can have a separate conversation about what are the pros and cons and what does this mean and why are we suddenly surprised? Because if you look at the trajectory of growth over the last 100 years, the line does not sort of do a hockey stick here. It's relatively flat growth, The difference is we call it the chunky peanut butter versus smooth peanut butter effect. We used to have growth that was smooth peanut butter because it was happening at residential scale. What you are seeing right now is for the next about 15 years, you're seeing the chunky peanut butter effect where specific tech industries are growing faster than the normal growth. And that is the reason we're talking so much about data centers, right?
All right, now that's a new one to me. I hadn't heard that before. So Daria, then Varun, each real quick, please.
Yeah, just a quick comment about actually the growth trajectory. What we see as an AI infrastructure company, that the workloads are actually moving from training to inference, and actually training is a way more energy intensive phase versus inference. So we will have to see how this actually the growth actually looks like. And another point I wanted to make, that apart from just the question of, okay, well, whether this will grow, the question is, does this energy is actually used to produce useful output? And this links back to efficiency. So I guess what the AI infrastructure, the whole area and the partnerships have to answer this question. How do we make sure that the energy that enters the facility actually results in a useful AI output? So this is what we are also like working with our teams, tech teams across the stack, starting from the data centers and hardware, and also ending with the software, because in my perspective, and I think many people would agree here, is that software is a great mitigating tool to energy grids and grid constraints when you can allocate the workloads in a smart way. So that's, my
Thank you.
take.
Varun?
Look, I want to meet you right where you asked the question, which is, does AI's growth mean it's going to take all the energy away from everybody else? Right? That's the central question. And for all of us here on stage, it's our job to make sure that folks feel like, no, the answer is no. There is actually a really positive set of benefits that come out of this. I love what Josh said, what everyone said. But Josh, the point you made about load growth can actually be a really good thing. It can catalyze demand for clean energy. And as we've been discussing with this trial, if the load growth is friendly to the grid, it actually helps to reduce price pressures for everybody, because it helps to pay down that fixed asset, that network that's on all of your bills. The last point I'll say is, we don't have an energy problem per se. We have a peak load problem. I want to change us from a scarcity mindset to an abundance mindset. There's actually a lot of energy out there that we can utilize almost all of the year. And these AI data centers that come online can actually be great citizens that lower your bills, that make the world more sustainable, and that make it possible for us to have innovation in a very community-friendly way. They should be the heroes, not the villains of your community.
There's a question here. Let's get, we only have 2 minutes, so quick question and quick answer probably from just one of you. But I do want to get another voice in here. Please go ahead.
Vivek Mittal from Afida Africa. We run an infrastructure platform. What all of you, I'm going to be controversial, and forgive me for that. What all of you have just said is essentially fluff. There's a lot of resources going to the top of the line, energy, capital, water, all of that's going, but there's nothing tangible that we hear about the benefits. What is the payback? Financially and in other stuff. So all of you have said something or the other about all the benefits, but nobody is ever not.
Sorry, payback for what? Payback for the software or something else?
For all the resources that are going into AI right now all over the world. When do we get the money back? In what form?
Okay. Well, I mean, speaking of fluff, that's a fluffy question. Payback for all the AI all over the world. But your general skepticism is noted. You're all here just to promote yourselves. It has been noted by the audience. But if the question of what is the payback for all of the AI in all of the world is a bigger topic we're probably going to have to discuss over drinks, sir. I will happily discuss it with you. My colleagues and I write about this every week, week in and week out. We're the Economist, so we take a tough-minded view on payback, and we'll discuss it. But in terms of very specifically, if any of you wanted to have a specific rejoinder to the gentleman about the payback of this technology and of flexibility, does someone have a quick answer, because we're just about to run out of time, on the set of issues we're discussing? Flexibility, maybe Steve, since you were the host for this experiment. What's the payback for you?
The payback is for our customers, which, as I said, it's a fixed cost network and it's lower unit costs for everyone. If we can find ways of getting these loads on, flexibly, that's it. So that's
the numerator denominator problem.
Exactly right.
Okay, very good. All right, so we're going to leave it there. Please thank my panelists. Go check out their stuff and make up your own mind about chunky peanut butter. Thank you very much.